We're going to talk a little more about disease control in this video. So the ultimate goal is to eradicate a disease, but disease eradication is actually a really difficult goal to attain. When we say eradication, it means completely eliminating the possibility for any new infections to ever happen, which means no human being has the disease and no animal or mosquito or whatever it is carries the disease. So there's no possibility of anyone ever being infected again. So worldwide eradication then eliminates all economic costs, both the direct epidemiological costs, mortality, suffering, treatment, and the excess burden of disease, the fear of disease contraction, and the activities that people take to avoid illness. Historically, only one disease has actually been eradicated worldwide, and that's smallpox. So congrats to public health. And so why is it so difficult to eradicate a disease? First of all, of course, there are the obvious technical challenges, just that you have to seek out every single human and non-human reservoir carrying this illness. But it's also, in part of that, means you're having to go to remote, potentially totally undeveloped regions, like, uninhabited islands, forest islands, to make sure that there's no mosquito there who has, malaria or whatever the case is. So it's really difficult to do that in that technical way. But there's also this other major issue that is a big economics challenge, which is the fact that consumer demand for protection of the disease is going to decrease when the disease prevalence is low, and it could completely disappear at very low levels. So basically, eradication actually becomes more difficult when you're getting closer and closer to success. Prevalence itself, it's determined in part by herd immunity. So if a lot of people don't have it, or if a lot of people are immune, then that means there can be a really low prevalence of the illness. And it also depends on how responsive the illness is to a vaccine, but also the responsiveness of consumer demand for vaccines to those prevalence rates. So as the disease prevalence decreases, we're going to look at a picture of this in just a second that'll help to illustrate what's going on. But as disease prevalence decreases, it's kind of an important point in this chapter that I want to kind of clarify. As the disease prevalence decreases, demand for self-protection is also going to decrease, which makes the rates of that disease rebound back up. In some cases, the only way to make sure that the last few people end up getting that vaccine is through a subsidy or even a government mandate, or sometimes both. So what's happening is, as the prevalence starts to fall, rates of vaccines also fall. As a result, the prevalence increases again, then the vaccine rate increases again, but still, the prevalence has not yet reached zero. It's just that it's falling, and so people are less inclined to make sure that they're getting that vaccine. So then they kind of bounce up and down for a while. So one example when this happened is measles in Ireland. The vaccine is introduced in 1985, and cases of measles fell pretty substantially from 100,000 in 1985 to only 135 cases, just 6 years later. So measles was not a major threat anymore, and people were less, serious about getting that vaccine. But then by 1993, the disease rebounded, and 4,000 new cases were reported, just 2 years later. And of course, in response, vaccine rates increase again, and on, and we have the bouncing up and down. Another example is in Nicaragua. They had conditional cash transfers. So conditional cash transfers, it's like a universal basic income, except it's not universal, it's conditional. So they had really high rates of tuberculosis, measles, and polio. So the government instituted a conditional cash transfer program where citizens would receive, some income if they agreed to get the free vaccine. So that ends up driving the price of the vaccine below zero, in fact, because you have a net gain, and people started getting a lot of vaccines. So the vaccination rate soared above 95% for each of those diseases. So that's one way of kind of getting over the hump of having, low demand for vaccines as the prevalence decreases. So next we'll look at a few more examples of economic epidemiology in practice.